derive this. So what we are doing here is we'll consider a simple expression, say k plus 1 to power 4 minus k to power 4. If I see this expression, so what this will be equal to? The k plus 1 to power 4 will be k plus 1 square n square of this and minus k to power 4. So the expression will be, okay, we should write little here. This will be k square plus 2k plus 1 square minus k to power 4. So we will apply the formula a plus b plus c whole square, which comes out to be a square plus b square. This is b, 4k square plus 1 plus 2ab. So this thing will become 2 4k cube 2bc, that is 4k 2ca, that is 2k square k to power 4. It's k4 and k4 is gone. So we're getting the expression which is equal to 4k cube plus 6k square, like terms added, 4 plus 2, 6k square plus 4k plus 1. Now you see this is the expression for this, right? Let me rewrite here. This implies this is equal to k plus 1 to power 4 minus k to power 4, like this. So let us put the natural number because we want to find the sum of cube of the natural number. So if I put the value of k here 1 2 3 till n, I get kind of sequence of 1 cube 2 cube 3 cube and so on, right? So we will try to put the value of k and see what. So in this expression, what we are going to do is put k is equal to say 1 2 3 and up to n. So let's say this is equation 1. So in this equation, so what do we get? If I put k equal to 1, I get 4 into 1 cube plus 6 into 1 square plus 4 into 1 plus 1 is equal to 1 plus 1 becomes 2, 2 4 minus 1. Simple. So it's as simple as that. Now put k equal to 2. So deriving this is very easy, you see. 2 cube, but you should do all these steps. 2 square, and see, you see you're getting some kind of pattern here. Plus 1 is equal to, this become 3 4 minus 2. Now you put k equal to 3, it become 3 cube. All right, plus 6 into 3 square plus 4. All right. Now if you observe the column, this is 1 cube, 2 cube, 3 cube. That is exactly what you want. And this is, though there is 1 square, 2 square, 3 square, that pattern is also being formed. 1 plus 2 plus 3 is also being formed. So we have already derived these two relations that you can check into the videos. So we will directly use these two things and then you will get this. So this thing is coming when you put k is equal to 3, this become 4 cube minus. We just understand what kind of pattern is being formed. So we leave this all the terms and we go for n, k is equal to n minus 1. So it become n minus 1 cube plus 6 into n minus 1 square plus 4 into, right, just a substitution, very easy. So n minus 1 plus 1 will be n cube, and this thing minus n minus 1. And when I put k is equal to n, I get 4. This thing become n cube and plus 6 n square plus 4, okay, and plus 1 should be, this thing is n plus 1 to power, oh my god, why did you write 3 here? This was the thing was 4 right here. Select it. So power 4, power 4, power 4 minus n to power. Okay, so we get this. Now we will add them column wise. You see, if you can observe, column number 1, all right, will give us what? This is column number 1. Likewise, we will add all the columns, the left and the right. What do we get? See, if I take 4 common, then inside I am getting 1 cube plus 2 cube plus 3 cube. That is dot 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 n cube. That is exactly what I am interested in. Plus 6 times the inside bracket, again you see this column you add, you get 1 square plus 2 square and n square, sigma n square, that is right, n natural number, square sum of the square of n natural number. The next term I get is 4 times sigma n, that is 1 plus 2 plus 3 plus, this goes up to n, all right. And I have one more term, if you see, this is 1 1 1 1 1 n time, so that gives me n. So should I write it here? Right, plus n is equal to, let's see what we get on the right hand side after equal to, I'm sorry, right, after equal to, you consider this carefully. What do you get? This 2 cube should get cancelled with this, right? So even if you see this n4, this n4 will go, and this term should get cancelled with some term here. So ultimately all the terms getting cancelled, I'm left with only 2 terms, 1 4 and n plus 1 4, right? So on the right hand side, that is negative 1 4. I'm getting, what exactly we get? This, okay, this thing, n plus 1 4, n plus 1 to power 4 minus 1 to power 4 is 1. So this is what we're getting. Once you get this, let's now write this expression. The first thing in here, yes, 4 times sigma n cube. The first thing is 4 times sigma n cube, summation n cube, plus 6 times sigma n square, plus 4 times sigma n plus n should be, can you tell me what is n plus 1 whole to power 4 will be? I think we solve this expression up there, k plus 1 to power 4, we can directly write that. See, where it is, k plus 1 to power 4, it was this, right? So in place of k, you will get 1. So is equal to k plus 1 square, or you calculate it once again. So this will be like n square plus 2n plus 1 n square of this minus 1. Now, since I'm interested in this, so I'll keep this one side. Let this be here only, 4 times sigma n is cube, sigma n cube, plus 6 times this we know, sigma n square, we have derived this in our earlier video, which is n plus 1 n plus 1 to n plus 1 divided by 6. I can cross out this 6. Or sigma n also we have derived before. So sigma n is equal to what? 4 times n plus 1 divided by 2. So, and then plus n is equal to, when I simplify this, what do I get? N4 a square plus 4n square plus 1 plus 4n cube plus 4n plus 2n square minus 1. This minus 1 plus 1, bye-bye. So what do we get on the right hand side? The right hand side and left hand side. So this is simply now simplification. So this implies 4 sigma n cube plus, when I multiply this thing, I get n into, multiply these two, which is 2n square plus 3n plus 1. And then you multiply this and this should cross out 2 times. Then you get plus 2n square plus 2n plus n is equal to, so the right hand side, what did we have? Yes, so let us write this. This thing is n to power 4. N to power 4. How many n cube? 4n cube. How many n square? 4 and 2, that is 6n square plus 4n. All right. So now I will keep this 4 sigma n cube on the left hand side and send rest of the terms to right. So let this 4 sigma n cube be there. This will imply 4 sigma n cube is equal to, all these terms should go on the right hand side. So first, let me first write the right hand side terms. These terms I'm writing first. So n to power 4 plus 4n cube, low n cube plus 6n square plus 4. When I multiply this becomes 2n cube, and it is transported to right, it becomes minus 2n cube. This becomes 3n square, so minus 3n square. And this become n, so minus n. Minus 2n square. Minus 2n, minus n. All these terms sent to right. Now we can add the like terms on the right hand side. And for how many n cube? If I see only one term, so 4n cube, no issue. How many n square I see? This is 6 minus 5, so minus n square. How many numbers? If I see how many n's? N4, n cube, n square is dealt. No, you have one more n square here. 6n square, 4n cube, and 2n cubes. Cube. How many n cube you have? There is one term, there is two. N square you see, 6n square, then 3 and 2, 5n square. Plus n square is left. How many n? Minus 3n. Do you have any other term of n here? Minus 4n. And 4n was here, which we should, yes, 4n. So 6n squared, it was not 4, it was 4n. So this 4n, that 4n, minus 4n plus 4n should be crossed out. So this 4n and these 3 crossed out. I get this. All right. So what we are getting is almost done. So we're getting 4 times summation of n cube is equal to, I can take any square common here, and this become n squared plus 2n plus 1. So this means 4 times sigma n cube. Can we factorize? You see, this is n plus 1 whole square. So sigma n cube, I can send this 4 on the right hand side. It goes in division, means this is n squared, this is n plus 1 squared by 4, which is same as n plus 1. N plus 1, n plus 1 by 2 square. That's what we said, sigma n cube.